my name is Kendall Koka. I am a researcher at Lowell Observatory at Northern Arizona University, and I'll be discussing a multi-angular photo-goniometry system that we've been developing for analyzing the reflective properties of planetary surface samples. So, our device directly measures Happy's reflectance factor, or REFF, which is defined as the observed reflectance of an unknown sample compared to the observed reflectance of a known sample. And we can use this REFF to determine things like the single scattering albedo, the single scattering phase function, and the surface roughness angle of the sample, which we can use to learn all sorts of different things about the properties of these samples. So the technology behind this is we've got this 3D printed dome, we've painted black on the inside, and we've got these illumination sources at known angles of incidence, and we've painted these reflective lines inside this dome at known azimuths. And so what happens is when we illuminate our sample, the light reflects off the sample and back onto those lines. And we have a camera on the system that will image these lines and then use our code to extract reflectance data from the pixel data along these reflective lines. And what's really powerful about this is it allows our system to be very, very fast and gather lots of data very quickly. And because it's designed this way, it can be very lightweight and it can be portable. So we can take it into the field with a computer running the code and just gather our data right there in the field. And what's also really powerful about this method that we've been developing is that not only can we develop these low mass systems, but we can also integrate this same technology into existing systems. So like if you're looking at the way a soil sample changes over time and you want to be able to know the reflective properties of it, you can paint these white lines inside of your system and use it that way. What we can also do is we can paint like the side of a spacecraft black and then paint these reflective lines over that and then have like a robotic arm with an illumination source and a camera, and we can illuminate the surface of whatever the spacecraft is landed on, provided it's in a dark enough environment, and look at the way the light reflects off of those lines and extrapolate these REFF values. So our current device gathers about 600 data points in a few minutes when it actually integrates. And what we can do with that data is we can send it through a interpolation system, and that interpolation system can give us reflectance maps like these that give us an entire hemisphere of estimated reflectance factor values. So we're very excited about where this is going. We think that this has got some really interesting technology driving it, and we're very excited to see where things go in the future, and I think we're going to have some really cool science coming up here very, very soon. Thanks.